couple of months ago, I made this effect in TouchDesigner that converts images into sound, and lots of people got in touch about this, and I decided to make a tutorial to show how I did this, and it's really quite simple and fun. The technique that I'm using is called a wavetable, and basically a wavetable plays a stored waveform back at different speeds that the user defines. And in this case, rather than storing sound data, I'm storing image data in my wavetable. This is a wavetable, and what a wavetable allows us to do is to store a set of information, in this case a 1-cycle sine wave, and loop that multiple times a second. Right now I have this phaser, which is basically mapping out how fast I read through that wave. It's set to 1, which basically means every 1 second it's going to ramp from 0 to 1, and those values correspond to 0 and 1. So basically one playthrough is going to map out this sine curve. So let's hear what that sounds like. We can see that we have some kind of signal, but we can't hear anything because basically we're hearing a 1 Hertz wave, and the minimum that we'll really be able to hear is at 20 Hertz. That's the lower end of our hearing, 20 cycles per second, but let's scale that up to something like 200. Okay, cool. So what we can hear here is that that wave is now being played through 200 times per second, and we're getting a tone that we can actually hear. Making a wavetable playback in TouchDesigner is actually relatively simple. We're going to need some kind of source. So in this case, I'm going to choose a noise chop, and we're going to go in and edit that a little bit later. And ideally, what we could do is just connect it to an audio device out. And let's see what happens if we do that. Okay, we get something, but it's not sounding very good. And this is partly because we need to force our noise to give us a time-based signal. Right now, time slice is off. Again, if we play around with this, it's not going to sound great, but the quick and easy way of doing something that's actually going to generate sound is turning on this time slice, going to channel, and setting our sample rate to something like 44,100. So now if we play, we get some audio. So we could put in maybe like a filter or something to smooth it out a little bit. But again, we're going to see that in this case, we're running through a lot of samples, so it's going to really crash our frame rate. So I've developed a little hack so that we can just put in a regular noise, or basically any chop-based input, and we're going to use a chop that actually generates time-based signal data and sort of hijack that clock to output our signals. Now, this is the way that I've found works for me. I haven't spent a ton of time exploring optimization on this. I just kind of put it together and it works. I'm sure there's better ways of doing this, but what I do is I create a wave, and this wave chop is going to allow us to generate signals like a sine, a triangle, ramp, square, kind of the basic synthesis waves. And obviously we could output this, but what we want to do when we've kind of completed this process is just turn it down, so we're just hijacking its clock rather than playing back the actual sound that's held within it. And we're going to play back this instead. But let's start out just by plugging it in. Okay, we got a little bit of sound, still not what we want. And I'm going to plug this into a resample. First off, in the resample, I'm going to go to the Common tab. I'm going to turn time slice off, and I'm going to go into my main resample page. I'm going to say new rate, new interval. I'm going to turn this end here to samples. I'm also going to change my sampling rate to 44,100. So in audio signal DSP, we want to have 44,100 samples per second to have a kind of a clear, consistent audio signal. That's the default. I'm going to set that. I'm also going to change my unit values to absolute. And in this start and end section, I'm going to say op wave1.num samples. And this is going to match the number of samples that we have in that wave. Okay, so now we've got something that we can see playing back that looks like audio. I'm going to turn this on in a minute. The important thing here is just to make sure you have samples selected. If you haven't switched, you might have it set to seconds, which is going to give you a completely different result. Okay, I'm going to play this back and let's see what happens. Okay, great, we have a sine wave. I'm going to turn it down, let's try a square. A ramp. Constant is nothing. So our choices here are we can keep it at a sine wave and just turn it down to 0, or better for our use case here, for what we need is basically just a clock, is set it to constant. And once I have chosen the wave that I'm going to use, I'm going to drag out this resample and I'm going to add a math in the in-between section. I'm going to connect my noise in and I want to combine those channels. So basically I want to use this to drive this, but I don't want to hear any of this. So let's combine chops. And now if I play back, we can hear that noise. So I'm just going to cycle through that for you a little bit. Just to revisit, let's turn it down. Just to revisit this wave chop, I've got my type set to constant. My period is set to 10, although that doesn't really matter. My offset set to 0, and my amplitude is also set to 0. If you have it at a high value, it's going to cause some issues, so just keep it at 0 or 1, but let's just say 0 here, because we don't want to hear anything. If you do want to use a sine wave, you can do some interesting sort of cross-modulation. Or you can just have it at a 0 level. Again, I'm just going to set mine to a constant period. So a few other things we can do just to smooth out this signal is we can add a limit to ensure that our values are between -1 and 1, just so we don't have any unnecessary clipping. And we can also add in an audio filter, and this can maybe smooth out that signal a little bit to be something a bit nicer. So let's have a little play with that. So you could move that filter cutoff. You could change the resonance. And you can obviously change that dry to wet mix of how much it is being filtered. You could play around with low pass and high pass, but let's just kind of set something that just kind of smooths out that signal a little bit. I'm going to turn up my sound for you. Okay, I'm liking that. And this is pretty much the little setup here. Some things that you could do to change how things output is, let's try that resample rate. So let's listen to it at 44,100 samples per second. And now at 4,410. We're going to hear how it's looping a lot more quickly. And if we want to maybe play back something that's just like a noise signal and not have it sound like a bunch of kind of tones, this would maybe sound more analogous to that. But then we also have that fast looping, so you could you could go in and change how fast you're going to sample there. But generally 44,100 is the best kind of sampling rate to use. We can go in and obviously automate this. And we can also use basically any kind of signal that we want. So if we want to take something that is a top, let's say we want to take a ramp, and we're going to turn that into some audio here. So let's take that ramp, we're going to go for a circular. I'm going to automate that phase, abstime.seconds. I'm just going to disconnect this so we don't hear anything. And there are a couple of things that we could do. We could sequence the whole of that slice. Right now we're just sequencing one row, essentially, for which in this case, because it's kind of consistent or fairly consistent throughout, that's fine. If you want to visualize the whole image, go to the crop tab, under crop, go to full image, and then under the first image tab, just set to output as a single channel. We can see here it's not loving that, so you could fit it to a square and you get back your original image. So even this could be sonified if we add this into that math. But mostly it's going to be easier if you just output one row. We're going to say just row. And what you can also do is you can scan through on that U. So by scanning through on the V component, basically what you're doing is you're moving from the bottom to the top. So we have at 0.5 will be right in the center of our image, so you get this central slice. As we go up and down, we move to the lower and upper extremities. So you can kind of choose what your what slice you're sonifying. In reality here we have a bunch of outputs for our RGBA, and we really just need to take one of those values, especially in this case where all of those channels are the same. So I'm just going to go ahead and select the red channel, and we can hear it's the same, and we have this output. And that was a little messy, but there you have it. This is a system for playing back wavetables in TouchDesigner. It's simple. There are a few things that you have to just change to make this work, but it can be pretty fun. I have used this technique to turn light into sound, make beats out of real-time images, and even turn images row by row into sound, which I can then transfer via audio or radio. This required a bit more coding, but was still very fun. I hope you enjoyed this tutorial. I have the file for making beats available on my Patreon, as well as a chop that will turn any chop input into a wavetable.